Hello friends, welcome to 360DigiTMG. As we were discussing about advanced prompt engineering topics, let's move further and have a look on self-critic. So in self-critic, uh, what is self-critic first? So self-critic is an ability of LLM to find and correct errors in their own outputs. Why is it important? It helps improves quality, creativity, and reliability of a response generated by the models. Okay. So there are levels of self-critics like basic level, intermediate level, and advanced level. So in a basic level, we'll check for obvious mistakes we done, ensures the response is accurate or relevant, or having a style guidelines or not, like that. In intermediate level, we look deeper for hidden biases or assumptions are there or present or not. Consider if these biases might affect the output. And in advanced topic, we'll have an examine the model's thought process. Like we'll use tools to see how the model thinks and identify any deviations from the expected reasonings. So there are some benefits also of having self-critics prompt engineering. So it will improve our output quality. Like by identifying and fixing errors, the responses becomes more accurate, reliable, from boosted creativity. It will have an analyzing prompts in detail, encourages new and creative ways to ask questions and get better answers. Like from debugging issues, finding and fixing problems like misunderstandings or logic flaws makes the model uh, perform better. Like from transparency and explainability, understanding how the model works and how it responds builds trust and makes its operational clearer. Okay, so let's move further towards generated knowledge. So in generated knowledge, uh, what is that first? What is generated knowledge? So it's a method where the LLM creates useful information about the topics before providing a final response. Why is it important? So it helps the LLM give more detailed and informative answers. How does it work? So it will have an initial fact generation first. Like before answering a question, the LLM generates a relevant facts about a topic. Like for example, for writing a blog post about spirit beers, the LLM first lists facts about spirit beers. And by using the generated facts, the LLM then uses these facts to craft more complete and informative responses. Like that's how generated knowledge works. And in there, we'll have least to most prompting and PAL, which we'll see in this slides. Okay, so this is first of generated knowledge, least to most prompting. So what is it? What is least to most prompting? Least to most prompting is a technique to help LLM solve complex problems. Like, uh, like it will create like chain of thought. It will have a step-by-step analysis, makes it easier for them to understand and respond accurately. Why is it important? So it guides the LLM through complex reasoning, improving their ability to provide accurate and relevant answers. And how does it work? So it will decompose the problems. Firstly, it will break down a big task into smaller or manageable tasks. And after that, it will have a sequential prompting where like tackle each smaller parts one by one at a time. See here in an example here shown, it will first break down the question into break down a question into small part, and then it will have a sequential prompting there. And then it will have a leveraging conceptual clues, like uses the output of earlier steps to inform the next one. It will help avoid the repetitions and focuses on building knowledge, right? You can see in this example, this is how it is shown. And now we'll have a look on benefits of least to most prompting. So it will enhance reasoning, Like it will guide the LLM through clear steps. In improving its reasoning ability, reduces the chance of getting lost in irrelevant information, right? And improved accuracy. Improved accuracy in the sense, breaking down a task into like smaller parts will achieve the accuracy. Allows the LLM to handle challenging problems effectively, piece by piece, like step by step. Okay. So just have a look on this. And then there will be this technique. This is called as program aided language model. Okay. What is this? What is program aided language? So program aided language combines the power of language models with code to enhance their reasoning abilities. Okay. Why is it important? It helps the language model solve complex problems by using both language models and precise coding logics. How does PAL work? So PAL works like, it will also work like our least to most prompting only. It will divide the thing into like problem decomposition. It will break down a big task into smaller and clearer sub problems. These sub problems will act as an building blocks for the solutions. Then code embedded reasoning. This is an addition to that of least to most prompting. Here what will happen? You have to use the short pieces of code like Python to solve each sub problems. These code snippets can do calculation, fetch data, or use the special libraries. Sequential executions. Here, the language model follows the prompts running the code at each steps. The results from each code snippets help inform the next steps, building a complete solution piece by piece. Like here, this is the example of chain of thought, and this is example of problem-aided language models. Here, in the first question, both are giving correct answers, right? But in the second question, see, here the question is, the bakers at the Bravery Hills Bakery baked 200 loaves of bread on Monday morning. They sold 93 loaves in the morning and 39 loaves in the afternoon. A grocery store returned six unsold loaves. How many loaves of bread did they have left? So the chain of thought process is giving wrong answer, right? Because it is only it is subtracting the unsold loaves also here. Like 6 is subtracting, right? But in problem aided language model, what is happening? It is dividing the question into subparts, breaking the questions into problem decomposition is happening here. And then, or because of this code embedded reasoning process, what is happening? The calculation is having, right? And after that, the output is getting, we are getting the correct output. Okay. Here, the return globes is adding here. Okay. The 6 should be add here. Okay. You can have a look on this question also. After that, there is tree of thought. Tree of thought. What is tree of thought? So tree of thought is a method that helps LLM solve complex problems by exploring multiple solutions. Here we are using multiple solutions. Yeah. Similar to how human brainstorms and evaluate different ideas. Okay. So why is it important then? It allows the LLM to think more like humans, considering various possibilities and finding the best solutions. Okay. Now, how does it work? It will also work like same. It will all have the same first thing, like problem decomposition. It will break down a big problem into smaller or manageable steps. This sets the stage for a tree of solutions to grow. This tree of solutions you can see here, right? Then branching possibilities at each step generate multiple possible solutions instead of just one. For each step, it will have a multiple solutions. We can choose from that multiple solutions, right? Each solution from a branch of tree represent different approaches to the problem. And exploratory reasoning dives into each branch, exploring and evaluating ideas, discard paths that don't work and nurture promising ones. Similar to that of brainstorming sessions. Convergence and refinements. Gather insights from exploring different branches, focus on most promising solutions and refine them into a final answers. Okay, see here in this example, it is showing this is the input output prompting. This is chain of thought prompting. This is a self consistency with chain of thought like we have seen here. Now, this is a tree of thought prompting. Okay, it will have in each step, it will have a multiple solutions, and from that multiple solution, we can choose from that which is better for us. And like our human brain works. Then there is self-ask. Self-ask. What is self-ask? Self-ask is a technique where the LLM asks itself questions to better understand and solve complex tasks. Why is it important? It helps improve the LLM's reasoning and accuracy by breaking down problems into manageable parts. Okay. How does self-ask works? It will have initial prompt. We have to give the initial prompt first. After that, self-questioning it will have. Like the LLM examine the prompts and creates follow-up questions to clarify its understanding or identifying smaller tasks that needs to be solved. Then answering the sub-questions. The LLM answers its own questions using its knowledge and the information from the initial prompts. After that, what will happen? It will generate a final answer. From the final answer, based on the answer to the sub-question, the LLM provides a final comprehensive answers to the original question. Like this. See the example here. Who was president of US when superconductivity was discovered? So, firstly, the LLM will ask itself, like, are follow-up questions needed here? So, if it is yes, then the again follow-up question will generate. Then, wherein we'll have, when was superconductivity discovered? Intermediate answer will have, superconductivity was discovered in 1911. Follow-up question will be, who was the president of US in 1911? The intermediate answer to that question will be William Howard Taft. So, the final answer to this will have the output. This is how it will generate self-ask. Okay, clear? After that, we'll go towards prompting, security and ethics in language models. So, there are always prompting, security and ethics there. So, ethical uses of language models. Firstly, we have to use the ethical use. Firstly, it should have awareness. Understand the ethical impacts of your prompts. Avoids harm. Don't use prompt that causes harm, discrimination, or illegal activities present there. Responsible use. Consider how generated content affects people and security. Then, second is bias and fairness. We'll have to address first the bias. Work to reduce bias in language models. Fair output. Ensure outputs are fair and inclusive. And thirdly, it should have a regular audit. So regularly check for and fix the biases present. Okay. Then there is user privacy. User privacy should be there. Data protection. Secure user data and prevent unauthorized access. Transparency. Clearly examine how user data is used. And after that, there is security measures. Security measures, there are like strong protocols for that. Like implement and update robust security protocols. Stay informed, like keep up with new security threats and fix vulnerabilities promptly. After that, there is again one more prompting technique that is called a chain of density prompting. In chain of density prompting, firstly, what is that? It's a method to refine summaries from the LLMs. Here, we'll discuss about the steps for chain of prompting. So here, firstly, what we'll do, in short, what we'll do here, we will choose a text. We will pick the text you want to summarize. Okay. After that, we will initialize the prompt, create a basic summary prompt to start the process. Then there will have a review summary. In the review summary, check if the first summary has too much or too little information. If it is having too much of information or too less information, then we'll check for chained prompt. If it is having a chain prompt, like we'll develop a follow-up prompts to adjust the summary details level. Then what we'll do, we will implement. We will have a refined summary. We'll have a refined summary. For there, what we'll do, we'll use these prompts to update the summary, we will add or remove the information as per our requirement, as per our need. Repeat if necessary. If our need is not matching the requirement, what we'll do, we will repeat the thing as we want. Adjust the prompts and summary until it has the right amounts of detail. So in short, in chain of density prompting, what we are doing, firstly, we are choosing our text, we are initializing the prompt, then we are reviewing the summary. Okay. After that, we are creating a chain prompt. After that, we are refining the summary, and from this refining summary, if there is having any information that is not here in the summary, we will again repeat the follow-up process. Okay. After that, there is Exot. Exot. What is Exot? Exot is everything of thoughts. Everything of thoughts. So here, this is an advanced technique. Okay. This is an advanced technique for improving the LLM models. Okay. Here is a simplified breakdown. What we'll do here, there is a Monte Carlo tree search module there. Okay. Think of this as an explorer finding different paths in a maze. It tests various ideas to find the best ones for the LLMs to use. After that, what we'll do, LLM solver. LLM solver, this is like a scholar using the explorer's finding to create well-informed and accurate solutions. After that, there is collaborative reasoning. From collaborative reasoning, the explorer and scholar work together with the explorer refining paths based on the explorer's input and scholars improving solutions based on the explorer's discoveries. This teamwork leads to better results than either could have achieved alone. So in collaborative, what we'll do, we'll have both, like Monte Carlo tree search also and LLM solvers also. Okay, to achieve a better results. After that, there is an output from this. First, what we have seen in earlier lectures, we have seen iterative promptings, chain of thought prompting. This we have seen now, self-critic prompting, tree of thought prompting, and this is our chain of density prompting, and this is our everything of thoughts. Okay. This will have a solution 1, 2, 3. From the tree maps, we can identify what is happening in each and every prompting techniques. Okay. Just have a look on all these. Then there are some LLM models. Here are some well-known LLM models listed below. Here are this we all know GPT 3.5, GPT 4 is from OpenAI, and some are from like Hugging Faces also, which is like open source models, and BERT and Palms are from Google. So what we are doing, some LLM models come with user-friendly GUIs, graphical user interfaces for easy use, while others are available as Python modules for developers to build custom applications. So in module libraries, what we are doing, see here in module libraries. Well, as I mentioned before also, some modules is having their separate libraries, such as GPT having OpenAI, BERT, we are having Google BERT, Palm, we are having Google.Generative AI. But apart from these modules, we are having some other modules too, like LangChain, Transformer, Semantic Kernel, like that. Semantic kernel includes libraries like OpenAI Chat Completion for accessing the GPT modules. These libraries provide tools to interact with and utilize various LLMs. So this is how. Okay. This is all for today. Thank you. See you in next lecture. Thank you. Bye.